Okay, hello, it is Friday. Oh, I got some glare here, right here. That's okay, it's from the window. Oh, somebody is trying to get in here. Okay. It is Friday, so the weather is nice. And it is Friday, so hey, it's like a win-win situation here. And you get to see my pretty face. There. All right. I just have to keep watching for people trying to get in. I need to set it up so I don't have to admit. You can just walk into the classroom. That's going to be my assignment for next week, to find that out. Okay, if everything else, if all else falls, there's always YouTube. This is how I learned how to hem my pants with my sewing machine. Okay. All right, so let's keep going. The last slide. Oh, one person waiting. Okay, got it. We have 88 people. That's a great success. All right. Now, this was the last slide that we stopped at yesterday, and it was about the F-clips. I really encourage you to go on YouTube and watch. I think there is something like a minute and a half long video on how to install those F-clips. And trust me, if you're getting into this business, this is going to be an excellent 1 minute and a half out of your life that you're going to spend to learn how to install the F-clips. Okay. All right. Next slide here. So we're going to take a look at some devices here. Short examination of types of switches. I'm going to ask you things like that on the tests. So for example, here's a single pole switch, and we're going to see another view of that in the next couple of slides. And here is a duplex, and here is a duplex receptacle. And here's the phone ringing with a cheesy sound here. Nobody uses songs for telephones anymore. All right. So here's a single pole switch, and we're going to examine that a little bit in a further detail. You don't? Okay. All right. And then there's a duplex receptacle, because it's a receptacle and it is a double receptacle in one package. So that's why it's called a duplex receptacle. And from yesterday's class, we distinguished we talked about two basic versions of the duplex receptacle. One was just a regular duplex receptacle for 15 amps. And this is the footprint of a 15 amp duplex receptacle. Later on in the next couple of slides, we are going to see something like a 20 amp duplex receptacle. It has a slightly different footprint, okay? And we also talked about the GFCI. I'm going to ask you what GFCI is, and GFCI stands for ground fault circuit interrupt. And the way it works is that receptacle, or the GFCI can also come in the circuit breaker version. Right? So you could have a circuit breaker in the panel, and that panel, okay, and that panel is going to supply the wires for the consecutive outlets. And if that circuit breaker is GFCI rated, all the receptacles that are on that circuit can be just regular receptacles, because the GFCI, the ground fault interrupt, is going to be taken care of at the panel level. Or you could also have a regular circuit breaker at the panel And when you are having a receptacle by a kitchen sink or a bathroom sink or whatever it is, close to water or whatever, outside, wherever it's required, then you can install the GFCI receptacle. And the GFCI receptacles, you can daisy chain them as well, except it's not the same way as regular duplex receptacle, because the regular receptacle, you just connect them in parallel, in parallel, in parallel. But the GFCIs, you're coming in and there are so-called input terminals at the receptacle, and there are output terminals at the GFCI receptacle. Okay? And if it's in a circuit, let's say you have a regular circuit breaker, regular circuit breaker, and then you have the first GFCI into the input, and from the output of the GFCI, you can install just a regular duplex receptacle. And that duplex receptacle also is going to be GFCI protected at the first one, because the first one is going to do the job. And how does it do the job? It senses the current of the supply current carrying conductor and the return current carrying conductor. They both have to have the same current. If the supply current is bigger than the return current, that means the current at somewhere along the line escapes somewhere, usually to the ground, and then this GFCI shuts down the power. Magic, right? All right. That ringtone, yeah. All right, so these are the receptacles. Now let's go on here. Let's take a look at the receptacles, how they are actually made. All right. Now the receptacle has they have tabs. Now you can see here is I used the wrong mouse. Here is the mouse that I'm going to use. Now here is the ground prong or the ground inlet. Okay. And now you have a shorter terminal and you have a longer terminal. How do they relate to each other? Okay. Now, the way I try to remember that is, if I'm standing, let's say if I'm standing, this is me, okay? I'm standing in the ground, on the ground, and the ground is big. My head is small. In comparison to the ground, okay? Ground, hot, ground is bigger than my hot head, okay? Now, if you look at this here, so here would be the neutral, which would be at the, oops, wrong mouse. Here would be the neutral, that would be in reference to the ground right here, okay? And this would be the shorter prong, that would be in reference to my head, that is basically much smaller than the ground I'm standing on. That's how I'm trying to remember that. Oh, somebody's trying to get in. Let them in. Welcome. All right. Now, of course, we're not connecting ground to this longer prong. This is where the neutral cable is coming in. And always remember, neutral is always white. White is always neutral. Why did I make a reference to the ground? Because the neutral should be at the same potential as the ground. So if you connect a voltmeter between this neutral and the ground terminal, you should have no voltage reading, or maybe some very small noise reading or something like that. So they should be at the same ground, or at the same potential. And of course, this here, that would be hot. Okay, so that's how we remember. Of course, this is the ground, and this is a neutral, which is should be at the same potential at the ground, but they are not electrically connected. They just should have the same potential. So that means there should be no voltage reading between them. And here is the hot terminal. Okay, so that's where the white goes, because white is always neutral. This is where the bare copper wire goes, because the ground or bonding wire is either bare copper with no jacketing or green jacketing. That's it. Right? And over here, we have other than white conductors, and that would be either red, if it's a 14-2, which has 2 current carrying conductors, plus 1 bonding wire or grounding wire. And if there's another one, it will be color red. So the voltage reading between the neutral and the hot, black, should be, in North America here, should be 120 volts RMS, root mean square. That means it's a working voltage. Okay. Or a DC equivalent voltage. Okay, so but it's basically it should read, if you put a voltmeter on it, you should read 120 volts or some value about that. Okay, now also between the white and the red, you should also read 120 volts AC. RMS AC. So here's 120 volts AC between white and the black, and between white and the red. You should also have 120 volts AC RMS voltage reading. Okay. Now, excuse me, because these two are out of phase, 180 degrees out of phase. What does that mean? Let me just erase myself here. What does it mean that they are 120 volt or 180 degrees out of phase? Well, if this is the neutral and this is a hot. So with the neutral and hot, you should have voltage going on that way. Okay. And if it's another hot, so let's say this is the black. We're getting too messy here. The camera view is there. Okay, so here's the hot. Now this is the black wire, and this would be the white wire. Okay. That means they are 180 degrees out of phase. If one goes up, the other one goes down. So if this is, let's say, 120 volts AC RMS, and if this is 120 volts AC RMS, so of course between here and here you're going to have.
Sorry, I couldn't quite hear you. Could you please repeat what you said?
Goodbye, Siri.
So
All
long.
right. So over here, you're going to have 240 volts, because 120 times 2 is, is 240, okay? All right, let's keep going. I think today is going to be a good day. All right.
Hey Siri.
Yeah, you can't do that because you're in my headphones. Okay, now let's keep going here. All right, now let me just turn on the other camera here. Can we see the view? Yes, we can see the view. Huh? Come on. There we go. Now here, we have the bonding terminal right here. Here's the longer prong that goes to the neutral wire. Here's the shorter prong that goes to the hot wire. Now, here are the screw terminals. Notice one of them is kind of a brass color, and the other one is going to look like a silver color. Well, silver is closer to white than the brass, and brass is closer to black than the silver. So the first thing you do is you connect neutral to the silver ones, and those silver screw terminals are internally connected to the longer prong. And of course, the brass terminals are internally connected to the shorter prong, and here's the bonding inlet, and that is connected to this bonding terminal. These are screw terminals. Also, I wonder if you can see. All right, look at that. Over here it says hot wire. Some of them are labeled. And over here, if I can focus it properly, and yeah, there we go. You can see that one shows white wire. And of course, again, see if I can go with the light here. Hot wire. Okay. Now, those little insert holes here, they are supposed to serve as also terminals. So you strip the wire and insert that in. I never use those because I don't see what's inside. I'm not sure if something is defective or not. I just try to pretend that they are not there, and I recommend that these are not used. Okay? Because you never know what the connection is once you put that thing in. This could be halfway out, and if you have a poor connection, you're going to have heat build up, and you can actually start a fire. So I recommend not using these. So use these screw terminals here. So this is the hot, this is the neutral, and also you can see here. Let me just grab my little screwdriver so I can point things. You can see there's a little tab here that is connected. That little tab connects this screw terminal to that screw terminal. And on the other side, you also have the same tab. Okay, it's a piece of metal that basically connects these screw terminals. If you remove those, you can cut them, or you can just grab them with, let's say, with needle nose pliers or side cutters or something. You can just rip them off. I'm not going to do that, and that means you're going to separate that, because these two screws right here, this one and that one, they correspond to this receptacle, and this one and that screw here, yeah, they correspond to this receptacle. You can separate them. Now, it doesn't matter which screw terminal you connect. Once these are intact, those tabs are intact, you can connect this one and that one. So this would be the hot wire, this would be the neutral, and you would have both receptacles active. If you remove that, then you're separating those. That's how you separate them. Okay. Now, that brings me to the point that you can actually install something that's called a split receptacle. So the way you do that, you leave the neutral intact. You don't touch that. That tap is being left. You remove that one. So the neutral is common for both receptacles, and you could have a separate feed going into this receptacle for the hot, and a separate feed going to that receptacle for the hot here. Why would you want to do this? Well, especially in the kitchen on the countertop. Well, in the living room, you have a TV plugged in, or maybe a vacuum cleaner, or some kind of a table lamp, and so on. So that doesn't take that much of power. It takes some power, but it doesn't take that much. Okay? Now, if you're having a kitchen countertop, you're going to plug in the morning, you're plugging the tea kettle, maybe a toaster, maybe some other waffle maker or something like that. And things add up, and if it's on the same circuit, you're going to flip, you're going to trip the breaker. So the commonly used practice is that especially in the kitchen countertops, you split those. So you run one common wire for the neutral, and over here you run one wire, let's say black. You probably use 14.3 gauge 12, because it is recommended that maybe 20 amp circuits, it will be different footprint. But with over here, you're only allowed to use 15 amps each because this is a 15 amp footprint. Okay. Now, you would connect black wire to this one here if this is separated, and that would go to the circuit breaker, 15 amp circuit breaker in the electrical panel. And then you would connect the red wire, which is also another hot, and it would service just that one. And this would go all the way to the electrical panel, and that will be connected to a separate circuit breaker, which will be also 15 amps. So instead of having 15 amps total for the whole duplex receptacle, now you have 30 amps total, because you have 15 amps dedicated to this one and 15 amps dedicated to that one. And it gives you a little bit of a headroom, more headroom than just a regular duplex receptacle. So if you plug in a toaster here, you'll be fine. And if you plug in your waffle maker here, you will also be fine. Okay, so that's the reason for using the split receptacles. Waffles sound like a good idea. Yes, Belgian waffles. Oh, somebody's trying to get in. Gavin, welcome, Gavin. Okay, so that is this scenario that I just explained to you right here. Can you use it? What does it say? Duplex receptacle has brass side tab removed. And okay, so that's duplex and split receptacles. A duplex receptacle has the brass side tab removed in order to make a split receptacle. So you know now what split receptacle is. Most common use is countertops receptacle in the kitchen and split switch receptacles in the living spaces. Wow. All I said was true. It must be because it's written. Okay. Okay, keep going here. Now, over here, devices used with gang boxes. Gang boxes, remember? Single gang, double gang box. All right. This is here. This is a single gang box. If this was a different one, the gangable box, if you have, this is also a single gang box because you just have 2 inches here. If you take this, because this is, you can disassemble this and you can cascade them together to make them multiple gang boxes. So you take this out and you just keep adding. So if it would be like that, that would be a double gang box. Well, these are 2 different boxes, so you cannot do it with these 2. But if you have 2 of those, you could just remove that from that side, and from the other side, you move the other side, put them together, you have double gang box. Right? So single gang box, double gang box. And of course, over here, this would be a single gang faceplate. Right? Okay, keep going. And okay, so what do we have here? Now we have a footprint of a 15 amp, and we have a GFCI, and we talked about it. Not going to repeat that now, so we know what the GFCI is. And then we have 20 amp GFCI. What's different between these two is the footprint. This one has the longer prong, shorter prong, and the bonding or grounding terminal. And this one has also shorter prong and longer prong, but that one has a little bit different footprint right here. So if it was a 20 amp device that you would plug in, you would, a device that, that would, excuse me, if the device is a device that actually takes 20 amps. And as I mentioned before, just remember a thing, the general rule about the load. The load does not ask for the power, it just takes it. It is going to take what it needs without asking. It just grabs the power. Okay? So if you have a 15 amp circuit, you plug in a device that needs, and is going to try to take 20 amps, you're going to trip the circuit breaker, because the circuit breaker says, I'm not giving you 20 amps. I'm only going to be able to give you 15, and that's it. You can ask all you want, but I'm going to trip it, right? Now if you have a 20 amp circuit breaker and you have a 20 amp footprint of the receptacle here, then if you plug it in there, you should be able to get 20 amps. And of course, you would have to have different gauge of wiring. It would be not 14 gauge, it would be 12 gauge for 20 amps. Now, if you have that footprint of a plug that is shaped like this, you just wouldn't be able to plug it into a 15 amp circuit, or duplex or a receptacle. So that's why. Can you plug in a 15 amp device that is going to need no more than 15 amps? Sure, you can plug in here because this one can give you more than you need for that device. Does it mean it's going to push 20 amps into that blender or some toaster? No, it's not going to push. The device is going to take whatever it needs. If it needs 3 amps, it's going to take 3 amps, and that's it. But if it needs to take 17 amps, you cannot plug it into 15 amps. Okay, you get the idea. Yeah? 3 amp trip to Denny's. Okay. All right. Must be some kind of an inside thing. All right, so now here is the types of receptacles. Here are the footprints. Okay, several different types of receptacles are found in a typical home. Each is designed for a specific job. Okay, so over here you have a 15 amp circuit or the receptacle with a bonding terminal or grounding terminal. Now, before 1960s, and you can still see some of the old installations in very old houses, you're going to see some of those. So, well, if it was installed, then if you were to be inspected right now, it would not pass the inspection. But some of them that were originally installed, they're still working. But if you get a new installation, you would never, ever put this without the grounding. Now you are required to run the grounding wire. Okay, so this is a 15 amp. This is also a 15 amp, and you can tell because it just has this sort of a footprint for the shorter and longer prong. Then there's, you see, 20 amps. It has a different footprint. Can you plug in a 15 amp device into it? Sure you can. But you cannot plug in a 20 amp device into this one because it just has a different type of a plug. Now this is a 15 amps, 250 volts. Of course, you see, you can only plug it in that way. So if you have something that it requires 250 volts, 15 amps, you won't be able to plug it in here, and vice versa. Definitely, you should not plug in a 15 amp device into this one or the well, I'm talking about 240 240 volts or 220, which is mostly used in Europe. This is mostly used in Europe and maybe Asia, and some other continents. North America is pretty much this type of a footprint. Those are a little slightly bigger in Europe. So if you're traveling to Europe, well, maybe in a couple of years after the COVID situation is gone, then you will know what I mean. If somebody already has traveled to Europe, you'll be familiar with this type of receptacles and plugs. Okay, now over here we have different footprints for a dryer receptacle. This is a 30 amp rated dryer receptacle, and here is a footprint for a 50 amp. So this is a 30 amp dryer, and this would be let the man. Okay, this would be here a footprint for a 50 amp rated range receptacle. What is a range? Range is considered an electric range, another way of calling an electric stove. What about built in 1800s? In 1800s, you would have oil lamps. without grounding. Yeah. No ground with the oil lamps. Okay. Other boxes and devices, single gang. So the electrical boxes don't always come in metal. Sometimes you're going to see plastic boxes, and of course, when it comes to a metal box, you just have a screw terminal, grounding terminal, or bonding terminal right here, and that basically connects because it's a metal. So that this once you put the screw, the grounding wire right here, the whole box is grounded. So that means if you touch it to here, if you put like a light switch, the light switch will be grounded through the chassis. Now, when it comes to the plastic boxes, you still have the grounding terminal here, but you can see that there's a metal strip going right to the screw terminals. So if you want to install a lighting or light switch or a single pole switch, or a two-way switch, then you because some of those switches, they do not have a grounding screw. The grounding is done through this screw terminal right here. So the chassis is grounded through this part. So you can see the ground will be connected to here, and then there's a strip run right up to the screw terminal, so the light switch can be grounded as well. Okay. Now here's a 4 by 11/16 square box, and underneath that it's a paper rectangular box or cube box, but we're talking about this square box. Usually those are used for junction boxes. Usually there are no devices connected or installed within those boxes. However, it is possible to install a device on those. Now, octagon box, 4 by 1.5 inch. This can accommodate 10 14 gauge conductors. And remember that page that was in the last lecture, which was yesterday. What is considered as a conductor? What do we count as a conductor? Or maybe there are some conductors that are in the box that are not counted. I'm going to ask you some of those questions as well. So I strongly suggest you review that part of the video. Fixtures, studs, and hickes. Now, if there is a light kind of a device, such as like a lamp holder with just a single light bulb, you don't need any heavy mounting there. You can just install it right to the box because this thing is not heavy, okay? But if you have some heavier equipment that is being installed, such as ceiling fan or whatnot, you don't want this thing to be installed just on the box. You need this this whole assembly mounted to the stud above the ceiling, so there should be a sturdy structure, and there are some there's some terminology of, well, for example, this part is called a stud, and that thing is mounted to the stud, the wooden stud, or whatever the structure is in the ceiling. This thing here would be called a hickey. This would be a wire nut. That would be a nipple at the end of the hickey, and here is a cap nut and what's not. I'm not going to ask you for to remember that. Once you start installing those, it will just sink into your brain with no effort at all. Okay, I just want you to know that something like that exists, and if you are dealing with something like, if you're dealing with mounting a heavier device, it's not enough just to have this thing mounted to the box, to the device box. The whole structure has to be connected and above the ceiling to a sturdy structure that's above. The box is just to house the wires, but there's a whole holding mechanism that is supposed to support whatever the device is if it's heavier, such as a ceiling fan. Okay. Now here, octagon boxes quite often are used for lamp holders. This is a lamp holder. A lamp holder is just another way of naming the light fixture. That is basically a screw on a light bulb right here. And that's it. That's called a lamp holder. Right? Okay, that's what the lamp holder looks like. It's a basic lamp holder device. Next couple of slides, I'm going to show you some details. Okay, now wire connections to common devices. So duplex receptacle, black or red conductors go to the brass screw. Okay. Come on. I need some. So what does it say here? Black or red conductors to the brass screw. Here is the brass screw or a screw terminal. And that's where the black goes because it's hot. Can we see it in the light? Hot wire. And over here will be neutral. We talked about that. White conductor goes to the silver screw. Uninsulated bare conductor or green jacketed goes to the grounding screw or a bonding screw terminal right here. Lamp holder, a black or red conductor to the brass screw and white conductor to the silver screw, and the uninsulated bare copper or green jacketed wire goes to the box connection only, because let's say this is here, this is the blown up version of right here, this lamp holder. Okay, so you can see a thread here. That's where the thread of the light bulb goes. And so that's the thread right here. And this is the hot terminal. So that's where the hot terminal of the light bulb goes. So this thread terminal, that goes to the silver, that is connecting to the silver screw terminal on the other side of the lamp holder. And here is the hot terminal. It goes to the brass screw terminal. Now, if you're not sure, well, easy way to remember, the thread is always the neutral, where the thread is, and the little hot nipple there, that connects to the hot terminal there from the light bulb. So, and if you hold the lamp holder in your hand, you can flip it both sides, and you can actually see where the connections are on both sides. But usually, the silver screw terminal goes right to the neutral, and the brass goes to the hot, which would be black or red. Now, where do we connect the grounding wire or bonding wire? Well, you see the whole assembly here is plastic. So you can't ground plastic because plastic is dielectric, it's an insulator. So if you touch plastic, you're not going to get electrocuted unless it's wet, all right? So then the current can carry through the water. But there's no way to ground that. So the grounding wire goes just to the box, and that's it. All right, wire connection to common device, single pole switch. All right, let's just go to the switches, jump to the switches here. All right, single pole switch, three-way switch, and a four-way switch. How can you tell which switch is which? Which is whistling, which is not? Which switch is which way switch? All right, now, single pole switch. A single pole switch. Yeah, terminal, connection. That's the single pole. You can close it or you can open it. Single pole switch, that's how it operates. It also could be called, if you want, it could be called a two-way switch, and I'll show you why. Now, here's a three-way switch. Three-way switch would be another way of arranging a switchable device. You have three terminals, and you have a single pole. Now, you can close that pole into that terminal or into that terminal, like this or like this. Three-way switch. Three-way switch. How many ways to get into that switch? 1, 2, 3. It has 3 screw terminals. Let's just count the terminals. A 1, a 2, a 3. 1, 2, 3. Three-way switch. And of course, the grounding terminal or grounding screw is not counted. Now, can you tell that by the same logic? Can you show? Can you look at this here? Four-way switch. How many connections? A 1, a 2, a 3, and a 4. Okay, look at that. Right? Just count the terminals. So now you can easily tell it's a single pole switch or two-way switch. But usually it's called single pole. Then there's a three-way switch and there's a four-way switch. Yeah. Later on, we're going to look at the three-way switches. Where are the three-way switches being used? Can you imagine a scenario that you have a stairwell going to the basement and there's a light in the basement and you go all the way up the stairs and you forgot to turn the light off in the basement, so you have to go back down and flip the switch off. So you can have two switches. You can have two switch on the bottom of the stairs. You can have a switch at the top of the stairs. So if you forget to turn the light off when you go all the way up, you can use the top switch. So independently you can control the light bulb that is in the basement by using three-way switches. There's also four-way switches, but we're going to start with three-way switch and the four-way switch. You're going to do some connections later on with Mr. Crouch or Mr. Hamilton when you work in the cubicles in the lab. Okay, now just one thing I want to point to you is you can see here, I'm not going to analyze all these connections because we're going to do it later on. It's actually going to be part of your assignment of drawing different, excuse me, scenarios when it has three-way switches. Now, you can see here, you can see white wire, which should be neutral, or you can see also a black wire, which should be hot. You see a grounding wire that actually should be green, but it's kind of like a beige color or whatever it is, or maybe it's like the bare copper wire. And here's also a red wire that should be, hot. Now, when you just open this device, when you open the box, what you're going to see is you're going to see wires because you don't know where the wires are going, okay, in the box. And you will see so that's, of course, that you should consider this thing as a hot wire. Of course, the red wire you should consider as a hot wire, but look at this, there is a white wire with some tape wrapped around it, okay? You're going to see that sometimes, and it's a commonly used practice, because sometimes when you have a cable containing certain amount of wires in it, and some of those you're going to have to use because you're not going to have enough wires. So all of them are going to be considered hot wires at some point. So what you're going to do is just to indicate that this is not a neutral wire anymore, you're going to wrap a tape around it just to indicate that this is not a neutral wire anymore. This should be considered as a hot wire. Sometimes people use magic marker or a permanent marker to make a marking on it, but the black tape is the most common way of indicating that. So sometimes when you open that, please do not open things yet. Okay, you're not authorized to open any outlets yet. Okay. You don't know enough, please, okay? But later on, when you see something like that, this is not just because somebody wrapped the tape around it and forgot to remove it. It is actually to indicate that this wire, this white wire, is not neutral anymore. It should be considered as hot. Now, here's a different scenario. When it comes to three-way switches, because the three-way switch, right here, this three-way switch is the switch that has to be used if you are going to connect that two switches on the top and the bottom of the stairs, and there's a light bulb in the basement. You have to use that three-way switch in order for that circuit to work. So the three-way switch configurations are going to be slightly different depending on the situation. What is going to make things different? Well, sometimes you're going to have a switch and a light bulb, right? Sometimes you're going to have a light bulb and a switch and whatnot. So there could be different configurations. And what we need, what our assignment is going to be, is for you to draw different scenarios of that. And I'm going to give you the scenarios to draw. Okay, so, and sometimes the power wire is supplied to the first switch. Sometimes the power is supplied to the last switch, or if you have switch, and a light bulb, so it could be supplied here. It could be supplied here. It could be supplied here, depending on which way the power is supplied. Usually the power is supplied to the lamp, or to the lamp holder, or the lamp holder device box. Okay, now it might sound a little bit intimidating on how to wire those things, but trust me, after I show you what I show you later on, it is actually funny simple. Okay, so just ride along with me, and I'll get you to that. One day we'll make it to California. Okay. Yeah, it's light work, boys. Don't stress it. Yeah, there we go. Right now, this here is a common device box. It's called handy box. Very common device. All right, come on, give me vision. All right, it just looks like that. You can buy them cheap at any hardware store, pretty much. Sometimes it is called utility box. Sometimes it's called handy box, or sometimes it's called a handyman's box. Pretty common device. Usually that this box is surface mount, installed in basements and some rugged environment, but it also can be incorporated into the stud work. Just remember to leave 1/2 inch, so leave some space for the drywall. So they could be mounted surface, could be surface mountable, or it could be flush mountable. Okay, box connectors. Of course, when you are running wires into the boxes, you can't just use a knockout, because these are the knockouts. They're called knockouts. You can just grab a bigger screwdriver and just knock it out. Yeah, or you can use needle nose pliers. I can probably push one with my finger here. See, they are easily removable. Yeah, see? Okay, so you can just run the wire in it, because there are some rough edges. It's not acceptable to just run the wire in it, so you need something that's called a connector, something like this. When you use the knockout, you put the connector here with a lock screw. So you put, whoa. Zoom it in a little bit. Focus. All right, so you would put a connector here. And once that thing goes on the other side, you just fasten this thing with a lock nut. Yeah. These are different type of connectors. They're metal connectors, what is called 2-screw connector for the NMD90 cable. And after this lesson, I'm going to prepare a video for your lab. So today I'm going to post 2 videos on our YouTube playlist. Please watch those, and I'm going to give you the links. This is going to be this lesson right here is going to be posted, followed by, after I hang up with you, I'm going to give you a lesson on the whole run through the first or the second lab that you're going to do. Okay? So these are connector. They're plastic connectors. These are pretty nice because they just snap in. They just snap. You don't have to loosen the screws. And the wires, there's a displacement element right here. It's a spring-loaded type of thing. Once you shove the wire in, that thing holds the wire in. Okay, so it's a nice quick installation thing. Some people like that. I you know what, this or the other thing, I can't say bad things about either one of those. Right? There are also different. It's a 440 connector. Same thing here. It goes in, and you use the set screw to push the compression tab right here oops, this thing is falling apart on me, to fasten the wire in. Okay. And over here, well, we've seen that already in the last slides. This is a square box used as a junction box. Now, there are different connectors that are going into the boxes. This would be an EMT, electrical metallic tubing, which is basically a pipe. That's it here. If you need to mount the EMT conduit into the box, you use this kind of a connector. And this is a coupler, because sometimes usually those pipes, those EMTs, they come in 10-foot section, but if you need to make a longer run, you can join those tubings using the couplers. So you put one here, you put one here, you fasten a set screw, fasten a set screw. You can purchase tools from Canadian Tire or Home Depot. I think we just gotta wait for the bookstore to get more. Well, I'm going to tell you this: if you don't bring, because we're not able to share the tools right now because of the COVID thing, and sometimes in extreme cases, we can share the tool, but we have to sanitize it first. But for the labs, you need to bring your own tools. And after you watch this video, there's going to be not many tools that you need, but you will need a stripper. You will need a stripper for sure. That's probably the most complicated tool you're going to get. And I'm going to show you how to work this in the next video, which is going to be the second video posted today. You will need that. You will need side cutters. You will need basic screwdrivers. That's pretty much all you're going to need. And maybe there's some other couple tools that I forgot to mention right now, but you need to bring your tools. Either way you get them, okay? All right. Now, there's also something that's called a box offset conduit, because those knockouts, they are not flush. So if this is a surface mount, then you see that knockout is not adjacent to the bottom of the box. It stands out slightly. So you will need to put the offset, all right, in order for the installation to be nice and neat. So these are called offsets. And the first pipe bending exercise that you're going to have with our class this term is going to be one of the last classes. You're going to bend the conduit to make an offset bend. Right? If you think it's simple, think again. All right, and then Mr. Crouch and Mr. Hamilton are going to take you through some more complicated pipe bending techniques. All right, now square box device boxes are mounted also on the metal studs, because with the metal studs, with the wooden studs, you can just screw things in from the side. They have holes, screw holes there. But for the metal studs, there are also metal brackets that you can install, or those boxes come that way. And this is a picture of our lab. We have in our lab, you have all kinds of those pipes installations. So after watching at this lesson that we're doing right now, once you go to our lab, just go around and take a look how some of those things are installed. Okay, and let's just see. That is the end of our class today. So wait for me to post this thing. If you jumped in late, you can just watch the beginning of it. It's going to take me about hours or so to process the video and post it on YouTube, because it takes time to download or upload. Plus, I'm going to also watch for this, because one of the sections has a lab on Monday. Watch this video, the second video that's going to be posted today, that I'm going to give you the whole run through the lab, and then you're going to have your lab instructor in your class that is also going to walk you through some of that. But I want you to come in with some knowledge, some previous gained information that you can turn into knowledge later by actually being able to do this. Okay, happy Friday, and enjoy your weekend, guys. Don't party too much, and if you do, party alone because of COVID. There it is. Okay, guys, love you, and I'll see you when I see you. Thank you. Bye.